Hi, thanks for braving the path to room 3 to get here. I appreciate it. Everybody enjoying the conference? Good. Anybody have a favorite talk so far? They've all sucked, nothing? You can't say mine, that's cheating. Something other than mine. Anything?
Kevin's always interesting.
What?
Kevin's always interesting.
That's true. What were you saying? I feel like if lunch is the best part of the conference, we're doing something wrong. But I know NDC's food is good. For my benefit, how many people here would call yourself a developer? Raise your hand. How many people would have other people call you a manager? Sorry about that. How about UX? A couple people willing to admit to it? You're not committed. How about QA? You're both UX and QA. Interesting.
We're a very small show.
All right. Project managers, Scrum masters, either of the two? No. A couple people willing to like really low say, yeah, it's me. How about psychologists? No? It has happened. Like you'd laugh, but I have had someone go proudly in the back. I'm like, oh, this is a problem. How many people have ever seen one of my talks before? A couple people, okay. So normally I talk a lot about brains, and this one is a lot more about code and brains at the same time. So hopefully we'll get some energy to roll up through the second to last slide of the day. How many people are London native? Handful? Most of you came in from kind of outside? Okay. How many people, this is your first developer conference ever? Hold up, keep your hands up. I want people to look at that because that's not unrepresentative. I tend to ask that question a lot, and a lot of people will be like, yeah, this is my first time. And it's almost always like a third to a half of the room, which is crazy. The field is just continuing, despite circumstances, continuing to grow by leaps and bounds. But welcome. I hope it's been amazing for you. My first conference was mind-blowing, which is part of why I'm up here now. So, a weird journey, but let's see. What else we got to talk about? We got the attendee party tonight. That's gonna be cool, right? How many people are going to that? Okay. And then you have a whole day tomorrow to look at your stuff. I know I've been to a couple sessions, mostly been anxious about this talk today, but that's my normal process. So this is the most awkward piece. It's just like we're sitting here waiting for things to start, but we can't really start until the actual clock ticks over. And you hate it, and I hate it, and everybody's just on their phones or not paying attention, including me. I got small bookkeeping details. That's my Blue Sky handle. I'm also the only Arthur Doler on the internet, so you can find me on LinkedIn or anywhere that's not an awful social media platform. There is a resource link if you want the slides that will also contain actual resources to every thing we are going to talk about today. But there will be, if you're not into like text links anymore, there's a QR code at the end. Yeah, I think that's it. We still have like 1 minute to go.
Gonna do a countdown like it's 2 years?
I feel like, I don't know, I've never had that. Keeping in sync might be hard with that, but.
Everything should be running on NTP, so about the same.
Sure, that's how, we all know technology works, right?
About the same time, can be a few seconds, which makes countdowns all.
Eventual consistency. Okay, let's get started. Welcome everybody. We're going to talk about today code archaeology. Hi, that's me. I'm Arthur, or Art. And usually I'm giving talks about psychology. So this is usually where I say I'm not a psychologist or a neurologist or a therapist or anything. But today we're mostly going to be talking about code and the human relationship with code. And I have been a developer for an embarrassingly long amount of time. I have been at this company for coming up on 12 years. You've never heard of it. It is in Omaha, Nebraska, which is where I live in the middle of the US. It was very, very cold there when I left. It is still very cold there. It's much nicer here. But you've never heard of them, but they let me come and do cool stuff like this. So they get a slide in the talk. All good talks will start with a story, right? So we're going to start with a story. Working at Aperture, I was put onto a project that was, how do I put this politely, bad. It had 4 different frameworks, 9 different languages. It had been written over the span of 20 literal years. The code at the very oldest that we ever found was code that had been written when I was in college, back in the Stone Age. And it was written in C, of course, this code, and then they copy pasted everything everywhere. It was hundreds and hundreds of thousands of lines of code. It was spread across the system, this massive system. You will see some of the shots of the architecture later. It was spread across, it was all initially deployed to this vSphere server. And I should mention the client was a, let's say, bingo operator, basically, a way you could gamble on drawing numbers randomly. And this vSphere server that they had was like, it was on-prem in somebody else's racks and completely full, like to the point that they were actually unallocating blocks from different volumes and moving it around so they had any kind of free space. It had multiple drive failures on it, which it definitely contributed to the fact that there was no freaking space on the drives. And it had been running forever and had been maintained by this company, this previous company who we were taking over for. And it was the most acrimonious standoff I have ever been part of. We received the code for this as a zip file, and they had intentionally deleted all of the .git folders from it, like gone through with a script and just wiped it. And they're like, that's the code. And we later found out that the code that they had handed us was not even what it was deployed to production. It was a branch that just happened to be what he had checked out on his machine. Oh God, the story is incredible. I spent forever looking through this code, fighting against it, trying to understand how it works. In the initial handoff that we had with this company's lead developer, he said something that is like, it's burned into my soul. It's one of those moments you will never forget. He's sitting there and just going, like, leaning back in his chair. He's like, yeah, it just works. Literally the first day we had full support responsibilities on this thing, the entire system went down because somebody connected to the watch site with IE8. We fixed that bug, but it caused a catastrophic log overflow that took down that server, which then took down all the other servers because they just didn't have enough space running on it. We lifted and shifted it to the cloud. We've done a bunch of stabilization work on it. We built them a mobile app on top of all of that. And it has a good story or good ending, but it's not about really the system per se. What I want to talk about today is how that project started to make me think about other people's code. And what I learned over the course of this project, what I was forced to learn, forced to appreciate, was that code is an artifact. It is an artifact created by other human beings for an explicit purpose and to achieve a goal. And there's a word for the process, for the techniques of discovering and analyzing human artifacts. It's called archaeology. If we think about the work we do as archaeology, it unlocks a method to help guide our thoughts about other people's code or our own code in productive directions, instead of just constantly cursing the developers who have come before us. It's going to help us sift through what archaeologists call the matrix, which is the dirt and the stone and the dust surrounding the artifacts that they're extracting from dig sites. And this talk isn't just for legacy code either, because let's face it, the real definition for legacy code is just code you didn't write. The same techniques I'm about to go over with you are techniques that you can use whether you're looking at moldy old Fortran that has never been run in the last couple decades, or an actual legacy system that you're taking over and maintaining, or a new project that you're starting on that is still being actively developed and maintained, or a library that somebody else has written that you suddenly need to understand how it works. All of these techniques will work for all of those situations. Because let's face it, unless you have a very, very special job, most of the code you will ever encounter is code you did not write. And once code is in production, it often has a very, very long lifespan. And disturbing it can be really dangerous if you don't know what its purpose is. So today, we are going to walk through a framework for thinking about code archaeology, a 5-step process. We're going to start with mindset, where we talk about curiosity, empathy, and Chesterton's fence versus the monkey ladder. I promise that will make sense. We're going to talk about surveying, exploring the hourglass, excavation, analysis, and progression, and then we're going to talk about how to practice code archaeology at work. This framework is actually based on the survey, extract, analyze framework that archaeologists actually use when they are analyzing stuff from a dig site. So the first thing to talk about is mindset. The most important steps in this process are going to come before you even look at the first lines of code. You have to get your mindset right. Now, when you are approaching other people's code, there's kind of a spectrum of ways you can approach it. I like to think of the two ends of this spectrum as two distinct points, one called Chesterton's fence and one called the monkey ladder experiment. Those are the two extremes of that spectrum. Now, Chesterton's fence is named for G.K. Chesterton, a British author. Weirdly, lent his name to the hometown, or to the town where I grew up in Indiana. It's very strange, but he was writing a book about reform, about legal reform. And he was talking about how, if you would, as an example, if you come across a gate or a fence in the road, he will not allow you to clear it away until you see the purpose of it. And so you can explain to him why it was there in the first place. Basically, the gist of Chesterton's fence is that when you come across something, it's there for a reason. A human being put it there. Fences don't magically appear. The other extreme, the other end of this spectrum, is an experiment that I've heard described. It is a thought experiment. It's never been done because it would never in a million years pass an actual IRB. Because it starts with taking a metal ladder and putting it underneath a hanging banana, and then you plug the ladder in. Then the fun part happens. You release a bunch of chimpanzees into the room. And the chimpanzees all go, ooh, banana, and shock the hell out of themselves on the ladder. Eventually, all of the chimps, just basic operant conditioning, understand you do not touch the ladder. It's very bad. Now the real experiment starts. You start swapping out chimpanzees. There are two forms of this experiment I've heard. One is with a shocking and one is with a water gun, like a fire hose. The basic gist goes, when you swap out a chimpanzee, it goes, ooh, banana, let's go for it. Now, chimps are generally pro-social animals, and they do often try to protect each other from harm. So if it's electrified, they will often try to stop, well, as the theory goes, stop the other chimpanzee from shocking the hell out of themselves. If you're using a fire hose, every time any chimp goes for the ladder, you just hose the whole lot of them down. And they all decide they don't like that very much. And I imagine that smells wonderful. So they will stop each other because they don't want to get hosed down. In either case, the theory goes that you can swap out the entire room of chimpanzees and you wind up with a series of chimpanzees who have never actually been shocked or hit with a water gun. They all don't go for the ladder or the banana, but none of them actually understand why. And at that point, the theory goes you could unplug the ladder. This is the other end of this spectrum. The difference in mindset between these two is that with Chesterton's fence, you are assuming that something is there for a purpose, for a reason. And with the mindset of the monkey ladder, you are saying that something is there essentially because of social norms, not necessarily because of any actual reason for that thing's existence. The other two almost more important pieces of mindset that you need are empathy and curiosity. Curiosity is going to be your fuel on this journey. If you do not have curiosity, if you are not curious about the code, you are going to give up the first moment that it starts to get hard. Or you won't even start at all. Having curiosity is asking questions like this. Who wrote the code? Who wrote this application? Why did they do it? What is the point, the intent, the reason of it? Why did they do this the way they did it? What's the story of the writing of the code? What circumstances, things surround it? What's the story of the code after it was written? If you don't ask yourself these, you're actually undercutting a huge part of the value you provide as a human developer. AI can't give us these things because it doesn't have visibility into them. So how do you cultivate curiosity? It's a weird thing to ask when you think about how do I become more curious, when a lot of us treat curiosity as almost a natural state. But it is a thing you can practice. It is a thing you can get better at. And you become better at curiosity by asking why. You unleash your inner 3-year-old upon the world, and you just ask, why is this thing the way it is? And then you keep asking why over and over and over and over again. It is an ongoing exercise. It's a practice. It's one that takes energy and effort to actually do. And so building it as a habit, as a practice, is important because you're going to need it to be built up like a muscle long before you actually need it when you're looking at code. But curiosity should be paired with empathy. And empathy is arguably even more important. It is going to be your guiding light on this journey. If you assume that the person who wrote this code was stupid or ignorant or lazy, your brain is going to stick with that easy and seductive narrative instead of trying to find out what actually happened. And the reason you do that is a stupid little thing in your brain called the fundamental attribution error. This is a cognitive bias. It's my favorite cognitive bias. Very weird to say I have a favorite cognitive bias, but I do, and this one's it, because it's so applicable to almost everything. The fundamental attribution error says that my behaviors, what I do, is dictated by circumstances, by what's happening to me. But your behaviors is because of intrinsic attributes about you. So as an example, I overslept due to insomnia, or maybe, overindulging last night, was frustrated by a poor coffee experience this morning. That's actually a lie. The coffee on like 4 or 5 is amazing. I'm overwhelmed by job stress. That part's actually true. That's my situation. Those are what drive my behaviors. But you are lazy, angry, and sloppy. See how that works? This mentality, and it's really just because it's really hard to hold another human in your head. Like holding the whole of another human is functionally impossible because humans are so complex and messy. And so we take a shortcut. Your brain takes a shortcut and just memorizes the attributes effectively, or arrives at attributes. Now, I want to be clear. I have been the person who said, who the hell wrote this code? When I was first put onto this project, we had a new developer. She just started and she was like 2 cubes away from me. And later she told me that she actually kept a notebook of all the things she heard come out of my cube. And when I went to her to ask for it for this talk, she said she lost it. I don't necessarily believe that, but I don't have it. So my point is, I've been there. It's so easy to not be empathetic. It's so easy to just be like, what is, I have to go lay down. It's natural, right? This is the habit. And I've been there, the tendencies, but you have to have what Zen practitioners call beginner's mind. You have to start from the assumption that you do not know why the code is the way it is. There's this thing called the Agile Prime Directive that says, regardless of what we discover, we understand and truly believe that everyone did the best job they could given what they knew at the time, their skills and ability, and the resources available, and the situation at hand. How many people have ever even heard of this? That is depressing as hell. It's very few people every time. This is a thing that was supposed to come along with Agile. If you have heard it, raise your hand if you've heard it outside of a retrospective. Okay, that's actually better than I expected. Most people encounter this in the context of retros, where you're sitting around and it's like, that's the okay time to complain. And then you have to put all that back in a box. That's a different talk about retros. But point being, you have to have this all the time. You have to assume that these people did the best they could in that moment with what they had. In other words, what I'm asking you to do is start closer to Chesterton's fence than to the monkey ladder. Now, I like when real life gives me fun examples for my talk. The thing is, archaeology as a field is not often very good at not arriving at a story, at having that beginner's mind. In fact, there is a joke that goes, how does an archaeologist say, I don't know? For ritual purposes. I love that none of you are archaeologists, but you can all get the joke. actually encountered this in a museum in Minnesota. This is a bunch of artifacts that they dug up from a hole. This museum is in Minneapolis, and this was found basically in a field, a farmer's field outside of Minneapolis. So all of these artifacts were in a hole, basically in that order. And I really appreciated that they had a section that's just like, we don't know. They put this in a hole, and it's some things, and question mark. But they almost couldn't help themselves. If you look at the tail end here, perhaps the tools were buried as an offering for rain and a successful harvest. Like, they almost can't stop themselves. And that's very human too. You want there to be a story. Your brain is not very satisfied with question mark. If you want to get better at empathy, you can actually start by practicing gratitude. Focusing on what's good in your life can actually help you be more empathetic to other people who may not have good things going on or may have actively bad things going on. It can also help to do your archaeology in a shared setting with somebody else, where you're helping keep each other honest and curious and empathetic. Front-loading those mindsets of curiosity and empathy is going to help you before you even open that first file of the code base. It's going to set you up for future success. And keep in mind, all the code you're about to write is about to become somebody else's legacy code. And sometimes, in fact, the idiot that wrote you in the past was you. So, once you've got your mindset in place, the next step is surveying. Because the odds are you're not doing this just for fun. Maybe it is like, this is a cool hobby you want to take up. Great. Most of you are going to be doing this in the context of your work or something. If you're working for like an open source, volunteering, etc., you have a thing you need to do. You're going to need to modify or augment the system you're working with. If you're going to do anything with the existing system, it helps to know what is the existing system right now. So to do this, you are going to need abstractions. And you're going to need abstractions to exist, which sometimes they don't. If you're lucky enough, someone has actually documented these abstractions, but otherwise you're going to have to discover them kind of as you go. To do this, to figure out how the system works, you're going to need to understand three things: the humans, the system, and the code, in kind of decreasing order of complexity, and certainly in decreasing order of scope. So I like to actually think of this in kind of an hourglass stage, or arrange it this way, kind of have an hourglass-shaped approach here. So let's walk through each of these levels and look through how this is going to look in turn. Let's start with the humans. Start with the humans as they are currently. Your first goal is to understand why the system even exists and why people use it. What was it created to achieve? What types of humans use it? What are those people's roles? What do they do? What are the goals of each role that uses the system? And if you're sitting there thinking, hey, that looks a lot like user experience research, you're absolutely right. This is effectively user experience research, which, because most of you are devs, leads to the question, but I just want to understand the code. Sorry, we live in the real world, and you can't understand the system without understanding the humans first. You have to understand why they're even touching this thing. So your goal for the output of this stage is basically a list of user roles and some goals that they'd have. Now, I want to be clear, this is not going to be complete, guaranteed. If it is complete, the system is trivially small. There are going to be things you don't know about, things people need that you have no idea even exist. There will be parts of the system you don't even know exist. Things running on a server far off under some guy's desk named Carl. But you need this, right? You need a concrete list of the things that they actually want to do. So like the player wants to be able to play a fair game of bingo, either as a habit or as a social activity, right? Those kind of goals. And then you can move on to the next step, the system, as it is currently. What are its parts? Where do those parts run? What are they written with, in, or on? Which parts talk with which other parts? Over what communication mediums? How are those parts built? How are they delivered? How does the code get to where it needs to go? The output for this step is effectively the architecture of the system. Now, why didn't we just start with calling it the architecture of the system? Because those diagrams are often inevitably wrong. The diagram we got for the bingo system was literally drawn on a napkin, and it was so laughably wrong as to actually confuse us for a number of months over what was running where. I want you to approach this, again, with that beginner's mind, that you do not know how things are. If there is documentation for the architecture, definitely don't just ignore it, but maybe don't look at it first. You want to discover what actually exists. And then you can look later, when we talk about documentation, about what's actually happening or what they thought was happening. Only now do we start to dig into the actual code. So once we start looking at the code, the obvious question, especially if you have something that's hundreds and hundreds of thousands of lines of code, where do you start with that? Because it's a giant ball of mud. And the answer is feature slices. That's where you start. Because the odds are that you have a goal that you actually need to change. Something was picked for you, you were handed a bug, you were handed a feature, the client contract that you have says you need to do these things. That's where you start. If you don't have one of those picked for you, pick one. Pick one that seems meaningful, or maybe the most important. Like in this case, being able to write tickets for players and know how much a tickets cost. That seems fairly important for a gambling system. Once you have that, you start with a component that role starts with, that they would first interact with. And then you start inside of the entry point that they would actually first hit. So that could be a route in a web app, that could be a call inside of an MVC, that could be an endpoint. It very much depends on what the user is and how they're interacting with that system. So now, right, we just need to read the code. Well, unfortunately, brains are ready and willing to get in the way on this front. How many people have ever read this book? Congratulations, today you learned. This is The Programmer's Brain by Félia Nermans, and it is a actually fairly short book, really fascinating book, and she talks a lot about how things get from your short-term to your long-term memory, what your working memory is, how those three interrelate while you're reading through code, and what that implies about how you should be writing code and styling code. We're not going to talk about, I could do a whole talk on this, right? But we're just going to pick 3 lessons out of this book. And the first one is chunking. How many people have heard of this as a technique? Okay. Chunking is this thing that brains do where if you're one of those people or you've heard of people that can memorize huge numbers of pi, it isn't that you can memorize actually more things than other people. It's that you've developed techniques, and one of those techniques is chunking, grouping them together in associations. So I come from the United States, and the example I like to use for this is phone numbers. In the United States, when somebody recites a phone number, it is almost always with the rhythm dot, 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 dot. Anybody that says a phone number is like da, dot, 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 they're psychopaths. Because you learn this from birth, like you deal with the phone numbers, that's how everyone recites them to you because they're all very similarly formatted. I went to look up for this talk how phone numbers are read in the UK, and I was like, wow, I can't really use that as an example. But it actually kind of works because you can't chunk them because of the varying length of the actual codes. And so it becomes, okay, you have to chunk it based on those rhythms, and it's not as habitual. Chunking lets you set and say, okay, instead of 10 numbers for a US phone number, it's actually only 3 things. And the number of things you can hold in your working memory at any given point in time is 7 plus or minus 2. At least that's what most of the research says. Some news research says it's actually less than that, which I guess we blame smartphones for. I don't know. What does that do for code? Well, take a look at this. I know you can't read it. I want you to look at the structure of it. This is real code from the bingo system. It is a giant if-else chain, right? And the thing, if you look at the individual pieces of the if-else, is that it starts to look very similar to each other. You have, 7 to 8 lines in each of these if-elses, each doing something very similar, but slightly different. You can actually chunk in code by refactoring. So instead of having to look at each of these lines, right? Remember, it's 7 plus or minus 2. So you've just filled up your working memory by looking at one branch of this if-else. Instead, you can refactor it this way. Just do the extract method refactor and pull this stuff out into their own methods with a name that makes sense for what it's actually doing. Now you only have to remember one thing. And then you could go crazy and like collapse this into pattern matching if you actually wanted to. But point being, you can chunk this code. You can do this refactoring, and now it's actually easier to read, easier to understand, easier to reason about, because you can hold it in your memory. Second lesson from the programmer's brain: refactor and document as you go. As you're working through a system, do refactorings that help you understand it, and then throw those refactorings away, which sounds like anathema. I did the work. Shouldn't I be committing that somewhere? You can make a refactoring that just helps you understand it, and then pitch it. Do that refactoring to actually chunk better. And then once you understand that code, go, okay, now I know how all of this works. You're building abstractions for the individual levels of the code. And once you have those in your brain, you don't necessarily need them in the code base anymore. If it makes sense for maintainability, sure, keep it in your head, keep the refactoring. Otherwise, you don't need to keep it. You can do it just as work. And be documenting as you go. As you find things out, be writing stuff down. We're going to come back to that lesson a bunch. The third thing, replace unfamiliar language constructs. As you're going through, if you're, say, not as hot with ternaries as you are with an if-else chain, swap them, rewrite the code. Again, especially if you're not trying to commit it, it doesn't have to be 100% correct. You can rewrite it to a thing that actually makes it easier for you to understand it and to reason about it, and then throw it away. So now that we've gone through that, we actually can just sit down and start reading the code. Follow through from that initial entry point to wherever it takes you inside of that component. Don't jump component boundaries yet. So when the code inevitably makes a backend call, a database call somewhere else, just note that and continue on as if it had returned. So as an example, for the bingo system, it starts with, of course it does, a custom launcher, a custom process runner that is controlled by a config file that it magically understands where to find. That goes to an SQL client, and that SQL client, and then there's also a transaction processing piece, a query processing piece that's actually looking for an object coming across the sockets that has a transaction type that it will actually do a switch on. Once you have that, it goes over to this query processing piece, and then it will actually start adjusting the database based on the things that are going on inside of that. I do want you to notice that this is C# code, the .cs. I want you to notice that there's some my's in front of all of that. And the old school developers in this room will know that that looks a lot like Visual Basic, like VB. That is a very common thing to do in VB. We'll get back to that later. And then, of course, we're not even done there because they're actually using the Microsoft DBML language to define the database. And then finally, it actually makes the call to the database itself. That's the path through that component without going into other components. So once you have read this piece, now you move back up to the system. Follow the code execution as it hits other components now. Go look when it said, oh, this goes to the database. Now you go to the database and see what happens there. In the case of the Keno thing, it's of course, or bingo thing, excuse me, it's calling a stored procedure that is of course thousands of lines long, because of course it is. Follow that code execution and update your diagram, your architecture diagram for the new components that you inevitably find. Again, it's extremely unlikely to be correct on first blush. There is a tool that we can use for actually tracking this stuff, and it's called an execution flow diagram. Execution flow diagrams came in with like UML, and they kind of got thrown out when we threw out UML, and I think it actually went too soon because they're really useful. You can track something like this. If you say, hey, I have a player placing a bet, and then there's a writer. I want you to know that's a person. It doesn't have to be a technical thing or a technical system. This writer then enters a bet inside of the bingo betting terminal. There's a play ticket transaction that's sent to the gatekeeper endpoint. The gatekeeper forwards that transaction to the BBT processor, which has a request play ticket authorization message to the data service, which then calls the get bingo object play ticket rules on the database, which returns some rules, which returns a response, which then makes another request back to the database, and so on. And then also down here, that's a physical object. It actually prints a ticket. So you can model these things, and they don't just have to be software processes. They can be individual people, any part of the system that you think is worth tracking the interaction between. So once you've got this and you're working with it, the next step is to go back up to the humans. Did the person get what they wanted? What is the eventual outcome of this process? And did it achieve the user's goal? Odds are no, because you've been tasked to fix this thing almost certainly. But you need all of this information because it's very, very important to understand what's actually happening. Your goal for surveying, the whole goal, is to understand what the system is doing and what the system should be doing. What's currently doing and what it should be doing. Because you cannot trust the code itself to tell you what the code should be doing. That's what you did all of that user research for up front. And every tiny bit of information you get is helpful to contextualize the code that you're working with. And context is very important. Now, you could stop here, actually. You've already done a big amount of work, and it's very valuable to simply just do the surveying for a system and identifying what needs to change about the system. But there's more value to be had here. And the next step, the next phase, is excavation. Once you have the lay of the land, once you know what code matters to that user and to their goal, it's time to get digging. Let's figure out why it is the way it is. Because once you understand the path through the code, it is very helpful. And if you understand, or to understand how the code got the way it is, you have to first extract the details about the way it has been in the past. And what forces shaped its creation. Okay, great. How do you get that? Well, the answer is really history. And I break it down into 4 types of history: written history, oral history, Git history, or version control history, and external history. So let's walk through each of those in turn. Written history is documentation. If you have documentation, congratulations. If you have documentation and it is accurate and up to date, I'm sorry to be the one to tell you this, but you are a brain in a jar and someone is running an experiment on you. We're just not that lucky. Documentation, though, can be really valuable even when it's wrong. And it is almost inevitably wrong because it's never completely up to date. Documentation is really often about the why of something and almost incidentally the how of something. And how they write about the how tells you a lot about that why. It will tell you explicitly what the purpose of a piece of code is and maybe some of the reasons why it is that way. Your ticketing system is history as well. If you have a Git commit, which we'll talk about in a bit, that has a commit or in it, a ticket in it, you can chase that back. Look at that ticket and is it part of an epic? Epics often contain a huge amount of information about the why of a system, why it was built that way. And if there isn't documentation, you should be taking Feli and Ehrman's advice and building it as you go. You do not want to lose the work you're doing. The next kind of history is oral history. And oral history is basically exactly that. If you don't have written documentation, you're not out of luck. If you have access to the people working on this system, they often have an oral history of the project that they carry around inside of their heads. They may not remember particulars about explicit pieces of code or tiny snippets of code, but they almost certainly remember large-scale efforts, refactors, moves forward. You might have to take their stories with a little bit of a grain of salt, but that's memory for you. And those stories are still their personal truth of what they lived in that moment. So, as an example, this is not the bingo system. This is actually a back-of-house restaurant management system. How many people know what a KDS is? Kitchen Display System. This is a thing that exists inside of fast food. If you've ever been through like a drive-through and seen a thing on the window or a screen that shows like orders in different columns, that's a KDS. They exist so that you can actually streamline and understand where an order is in the process. So when it goes through like from the burger making station to the getting fries station, you hit a thing, a little bump bar on the bottom of it. And that moves it along in time. And so you can actually understand the flow of how an order moves throughout the actual restaurant. I was tasked with building a report. They wanted to know how long something was sitting in the window. So I needed the difference between 2 different bump points, bump times. And the table that I was looking at for this had, okay, store ID, view ID and view name. Is the KID a view or is it an item? Wait, is it a destination? What's the display group? And then once you start getting down, I need a timestamp, but there's like 7 to 9 times in here, and I'm really confused about which I'm actually supposed to use. So I actually just went to the lead on the project, and I said, help. This makes no sense. And he said, oh, well, first, you want the bump time. And then second, there's this wholly other table that you didn't even know existed over here. That's the destination map that maps between the KDS ID or the KDS number and the destination ID. And the destination ID is what shows up over here, but you actually need the difference between the client provided numbers, which is the KDS number. We'd never have figured that out. It was nowhere in the code, nowhere in any kind of documentation, entirely in oral history inside this guy's head because he'd been on the project so long. Even non-technical folk can actually help here. Project managers don't necessarily have their nose day-to-day in the project, but they almost certainly remember major upgrades that took forever, or a Scrum Master remembers the endless cavalcade of tickets related to the migration to the cloud. The third kind of history is version control history, because Git remembers everything, whether you want it to or not, unless you rebase it and it forgets. If you can effectively use your version control well, even if it's a mess, you can maybe find out why code changed and exactly what changed, and maybe even why, if they wrote good messages for it. Everybody has access to something like this if you're using an IDE. You can actually just open what they used to call blame on the left-hand side. Now they call it annotations, which I feel a lot better about because usually it's my name over in the left. And once you click on the thing in the left, you'll see a commit, a row of commits down here, and it will show you that change in a flow. That is a very tiny window, and it doesn't look much better when you make it the whole size of the thing. So if I'm actually working on an archaeological dig, I use a better tool for it. This is Git Kraken. They don't pay me to say this, but I actually really like this tool. In fact, I pay them to say this, which is very strange. Okay. I'll have to look at it later. Either way, any visualization tool, it doesn't matter if it's Source Tree, Git Kraken, Git Tower, these can be better for helping you actually navigate through the history of the code better. You can also actually look, if you're just getting into a system for the first time, at the most and least changed files inside of a system, because that can tell you a lot about what's important and what's not important. Branching patterns can actually tell you a lot about how people worked. If you see branches made off and then merged back, they're probably using some kind of Git flow-esque pattern. If they have a single line of commits, they're either squashing or they're doing some kind of trunk-based development. And the commit message can also tell you stuff about that. Also, be kind to future archaeologists. Please leave a good commit message. I can find out the how of what, or the what of what you did simply from the diff. Tell me why you did it. That is more meaningful. And leave a clean commit history. WIP tells me nothing. Temp. The fourth kind of history is external history. And this one takes a little bit to explain. The tools we use to write software, the frameworks, the libraries, the toolkits, leave shapes inside of our code. They force our code to conform to certain shapes. As an example, how many people have ever heard of this JavaScript library? Nobody. It's fine. Nobody really has. So you have, okay. More people have heard of its younger brother. Redux was a state management library, is a state management library for JavaScript. Very popular in Angular, also very popular in early React. And the thing about Redux is it's complex. It's doing a lot to maintain state in a very particular way. You start off with a view. That view is executing actions, which are, depending on how you have this set up, executed by middlewares that send things out to the API and back. And then those things, those data pieces flow through a reducer, which combines them into a single unified state store. That state store is then handled through selectors back to the view. This is updated in a singular flow until basically it stops changing. The thing about Redux is that it was designed for a very specific purpose and a very specific thing in mind, which is that these actions should be what's called idempotent, which is that if you do them twice, it doesn't actually change the state again. It just sets a thing to a thing and then doesn't change it from that moment, unless you call a different kind of action with a different payload. And this was really useful when, say React didn't have useState or different state management libraries. The code that typically I've seen this in is more or less using this as a glorified data store for its API, which there are better, cleaner, smaller libraries out there for. The thing and the reason why Redux is the way it is it used to want to be this magical little tool that let you do something called time travel debugging. theoretically, you could scrub back and forth in time through all of these actions and see when something changed inside of the state. And there was even a magical thing that they wanted where a user, when they encountered an error on your site, would hit a button that would send all of the actions they'd done to you, so you could have exactly the state that the user did when they encountered the error. And there's two problems with that. One, I never saw anyone do it. And two, I've never seen a user hit a submit a bug button. But the code is the way it is. And I had a junior developer come up to me and he was like, why does Redux have so much boilerplate? Because there is a lot of boilerplate. And my answer is, all right, sit down while Uncle Arthur tells your story. And he immediately regretted his choices. But this is why. The intent of the person doing this library, building this library, the intent of the person adding it to the code base shapes all code going forward that actually uses this. And even once those things are gone, they still leave a shape on the code. As you're going through this process of digging further, you want to be trying to establish strata for a system that has been lived long enough, or eras of the system. So for example, the back-of-house restaurant management software had an ASP VB.NET era. It had a Backbone Marionette era. It had a JavaScript React Redux layer and a TypeScript React Tanstack Query era. All of these were actually running concurrently, which is really kind of crazy. They had two different servers running, one of each of the top two. And then for the bottom two, they were running concurrently. Well, it all compiled the JavaScript anyway. And if you think about these kind of geologic strata in the matrix around the things you are uncovering, it can help tell you a lot about that code. Not just when it was built, it can tell you what were the circumstances and the procedures and the habits and style about that thing, about when it was created. And they're essential in building a story of the system. The third step is analysis. Next, you're going to be reconstructing the story of what happened. Now, that might seem easy because brains are story machines, and I guarantee you already had a story in your head. You've gone through the first two steps, and your brain is like, here you go, this is why. And I guarantee you that that's probably wrong. It's riddled with biases and unconscious assumptions and judgments. Now, your goal here isn't to find out the true story. That's going to take way too long, and it's probably not even possible. You just don't have enough data. Your goal is to find a less wrong story, one that's more correct, more useful than the default story your brain provides. Well, how do we manage that? There are 4 behaviors that I talk through that help you assemble the story in a way that embodies that curiosity and that empathy. The first of these is fleshing out the cast. As you look through the code, do check that annotation thing on the left. See, who are the people working on this? Who were or even are still the people working on the code? What are their tendencies and their habits? What is their sense of style or taste? David Whitney, who I'm sure you've seen one of his talks, hopefully, talks about developers having a sense of taste, code that is good to us in the sense that there's music that sounds good to us, ways we like to write code. As an example, maybe Claire likes writing code that's very DRY and very well engineered, maybe a little too engineered. On the other hand, maybe Howard is very focused on achieving tasks, accomplishing tasks, sometimes more interested in doing that than on any actual engineering work. If you understand those tastes of the people working on the project who've come before you or working on it right now, it helps you understand where they're coming from and what they were trying to achieve. And that actually also goes for, again, non-technical people on the project. They don't show up in a lot of the histories. It's harder to get information about them. But you better believe that the way a product owner creates tickets, writes an epic and creates the tickets associated with it, will shape how that thing gets written. The second behavior is determining conditions. What were the situations that surrounded the writing of that piece of code? Or the writing of the entire system? How did those situations shape the behavior of the team or the individual that wrote that code? What resources did the team have? What resources did they lack? What strata is that code from? What was the style at the time? What now commonplace solutions and processes didn't even exist when that code was written? What were the organizational rules and processes that shaped the creation of that code? What other projects were going on? Was this a single person effort whilst everybody else was working on some massive thing? It probably doesn't have a ton of resources or time associated with it. That code you saw earlier that was C# that looked a lot like VB was written by a guy, a developer, who was handed the option to rewrite the system in C#, which he very much wanted, with no training in C# and 3 months to do it. And so he wrote what he knew. We ended up hiring that guy. He was a really good developer, is a really good developer. He just was constrained by what was available to him in that time. Nobody to teach him idiomatic C#. And no time to go just research it himself. As an example, if you are old JavaScript dev, this will look familiar. This is Backbone marionette code. If you're a new JavaScript dev, you will note that there's a lot of periods in all of this. We're using this all over the place. Not all the things which are very much not in style now, but this used to be the new hotness. And so it is easy to condemn this piece of code and saying, what are you doing? This was what the code used to look like, right? This, as the kids say, this is what peak performance looks like. The next behavior is looking for similarities. When you are working through the code, it's not English. We almost never have enough time to do the things we want to do, right? That's just life. Put more cynically, the work we have to do will often expand to fill the time we have available to do it. And also, software is hardly a scientific exercise. And there's rarely a completely correct answer or solution. And so what that means is that when we are encountering something that we have, say, encountered before, we've solved before, we reach for the exact same things that we used last time to solve it. Because they did work before, and we just don't have time to research the new things or the optimal way. And that also conflates with the fact that we confuse familiarity with correctness or rightness. When something is familiar to us, we're often emotionally more attracted to it, simply because it is familiar. What that means in a code sense is that if you encounter a piece of code written after another piece of code, and the later one looks like the former, and they were written by the same person, they were probably patterned off each other, even if that was unconscious. So as an example, on the back-of-house restaurant management software system, I was working on building out their data warehouse. And some previous developer had started trying to do this, and he built a table that was this facts table, this checks table. And you got all the things you might expect from a check, but then he had like a different table that was check items. And then beyond that, he had a different table that was check discounts, and then one for check voids, and then one for check returns. And I was very confused because you're building at that point a star schema around your facts, which is not how that is supposed to work. And I looked at this and I'm like, because I've been on the bingo project, I was like, why does this look this way? And I went back and looked at the previous work this developer had done, and they'd been in charge of building up the materialization tables for this project. Now, they were using SQL Server. SQL Server doesn't have materialized views, so they needed some pre-calculated values. These tables looked exactly like the materialized views that they had inside of the system. Is that wrong? No, the guy started with what he knew. It's not going to be the best data warehouse, and so now knowing that, I said, cool, I can actually get rid of these and build out a different one that actually is set to the right grain. But understanding that similarity between those two things is what helped me unlock and move forward. The last behavior, useful analysis, finding that story, is divining intents. You want to figure out why, the goal of the author of the code. What were they trying to achieve? If you can divine their intent, it is so much easier to make changes about that code. You're ultimately trying to figure out, is the code the way it is because it's a Chesterton's fence, or is it a monkey ladder? So you have the cast, you have the conditions, you have the code, you have the backstory. It's time to write that play. Sit down and ask yourself, how did the code get this way? Remember, be curious, have empathy. They almost certainly did not want to write terrible, bad code that didn't scale. Once you have that whole story, and it's maybe just of a tiny part of the code, it doesn't necessarily have to be for the whole system, but maybe you do have the whole system. Either way, now is the moment to ask yourself, why did we do all of this again? The answer is, hey, you remember you were trying to change something? Somebody told you this didn't work in this way and you need to make it work? It's real easy to get your own goal lost when you're trying to think of goals of every other actor involved in the history of this system. So this is the moment that you bring it all back. Circle it around on what you actually wanted to achieve. And now you're in a much better position to achieve that, because once you understand the way the code is and why the code is the way it is, it's so much easier to understand how to change it. Now is the moment when you ask yourself, if the previous code was constrained, are those constraints gone? If the code was affected by similarity to previous code, should it have been similar? Or was it anchored by somebody else's choices? Was the person's intent incorrect? Or did the needs change over time such that it became incorrect over time? What strata is the code from? How is the code in that strata different from the standards and practices of the current era you're working with in the code? Both internal and external to the team and to the company. How does it need to change to get to the place you need it to be? The story should be the foundation for all your future work on this code. Once you understand why the code is the way it is, it's so much easier to change it. Or blow it up entirely. We are often very gun shy as senior developers and mid-level developers to do a rewrite. And that's because we've often stepped on that rake before. But if the situation has changed so drastically from when this code was written to now, it might be unsalvageable. But you will never successfully rewrite a system or even a tiny piece of that code without understanding why the code is the way it is. You will rediscover all of the things that shaped the creation of that code, and you will rediscover them as an endless succession of failures and bugs and failed UAT acceptances. If you come across a system and it's writing a whole bunch of CSVs for reports, and one of them is a TSV, and you go, that doesn't make sense, and you change it, you're gonna find out there's a guy named Phil 3 floors down, and Phil's entire workflow is based on this thing being a TSV, and Phil has now decided that his entire mission in life is to make your life hell until you change that back. And unless you are certain that Phil exists or certain that Phil has been fired, it's hard to make a call either way on which way that code should actually be. But this whole talk has basically been a prelude to a talk on refactoring. Because once you have the code, if you are going to change it, you follow refactoring patterns to do so. A bunch of different places to look on refactoring. People's talks on it, like Emily Bosch's talk, refactoring from Martin Fowler, working effectively with legacy code, refactoring to patterns. Again, all of these will be in the resources of the description of the slides, basically. The description box will have all of these resources in it. And I've read almost all of these books, and they're all very good still. Also, write down what you figured out. You just did a bunch of work and you don't want to have to do it again. Consider it a favor to future developers or to future you. So what could you do with all of this tomorrow? Start documenting your current system. And you want to make that a team task. And you also want to document your current choices. Architecture decision records are currently the hot way to do this. I find them very useful. Fun fact about ADRs, you can write an architecture decision record about a decision you weren't part of. You could do that, nobody can stop you. If you find out the circumstances surrounding a decision that was made in the past, you can create an ADR about that decision that says, oh, here's what I found out. It's a nice way of documenting things that you found throughout this process. Start practicing empathy and curiosity. Both of those are muscles that are going to go stronger as you use them. And it has to be a practice, an active one. You can start by just, when you encounter code that you haven't encountered before in your system, walk through the phases just for that new piece of code. Maybe get a partner and try doing it together. You don't need to exhaustively document the system from start. You can start with small pieces as you need them, as you work through this. And then build an acknowledgement of that effort into your tickets, into your estimates, which I know we're not supposed to do anymore, but we all have to do them. You do not want to make this mandatory hidden work for people, where suddenly they're having to work extra to do all of this stuff. If your boss, if your project manager, your product owner is skeptical about it, do it on your own, and then start to tell them when you start saving time. When the story of the system begins to save you time over time, make something easier, It means you don't have to figure out how something is or how to change it in the future. Or all of this work up front made this into a 5-minute change. Tell them about it. Show them that value. The value you have as a developer is not simply the artifacts of code that you produce. So let's sum up. This is the framework you should be using for code archaeology: mindset, surveying, extraction, analysis, and then progression. For mindset, remember Chesterton's fence and the monkey ladder, and please start closer to Chesterton's fence. Build your curiosity daily and practice empathy towards those who wrote the code. For surveying, start with one user goal and work through the hourglass: the humans, the system, the code, and then back up. For excavation, find the forces that shape the code's creation. Look through all of the histories available to you, and opinionated external libraries as well. Establish strata when the system has been lived long enough. For analysis, flesh out the characters, find the backstory, and then write that play. For progression, recontextualize based on your own goal. Decide if you should rewrite or just refactor. Use the story to guide your next steps, and then write down what you found. The temptation to believe that every other developer is an idiot who doesn't know what they're doing is extremely strong. Trust me on this one. But if you can figure out how to use code archaeology effectively and engage in the practice of it, it can unlock an entirely different way for you to read and think about and process code and dramatically increase your own power. I want to thank you very much for listening. Again, if you want the slides with the resources, that bit.ly link or that QR code will take you to the bit.ly that then goes to slide deck or speaker deck. I will be up here if you have any questions, or you can catch me at the attendee party, or you can catch me all tomorrow. Thank you very much for coming.